Okay, fine. So let's begin.
So the link will be same on the calendar. That is, you upload the recording local. After that session expire or end,
You're
the
talking
link.
about the difficulty level.
In
No,
the
sir.
calendar, the YouTube link for this live session, you will update the YouTube link, correct?
Yeah, yeah, yeah. I'll update the YouTube link.
Okay, thank you.
Okay.
Okay.
Okay. So we'll discuss these questions. Okay. So these are marked. Are you able to see the screen?
Yes, sir. Yes, sir. We are.
Is the font size okay?
Ah, yeah, yeah. It is okay. It is
Okay.
okay.
So what I'll do is, unlike the unlike our previous solve with us, okay, I'll give you guys some time. Okay, I'll give you guys some time, and after that we'll discuss solution. Okay. So let us look at this one, the first one. Okay, it's not so difficult one. Okay,
I
you are
think
given
we
a
have
function.
already done, Vishal has already done these things.
Vishal has already done this mock
Almost, yes.
almost.
No, sir, the mock wasn't discussed.
Yes, sir. Mock wasn't discussed.
Yeah, yeah.
No, Vishal,
Because
what he did in the solve with instructor session, I mean, similar questions were discussed.
okay, you mean the similar questions? Yeah, obviously it's
Similar
going to
or
be
maybe
more or less
same
similar question.
question. Similar or maybe same questions.
This mock was released yesterday, maybe yesterday or day before yesterday.
Yeah, and
Yes. So,
that
so
session was day before
what
yesterday.
we had discussed earlier, mock questions are either same or almost same.
Yeah, I think the same question given in the revision slides.
Okay, okay. Still, we'll be discussing this. Okay, it's all right. Okay, or else what we'll do is I'll just discuss like how to do it, and then we won't actually solve it. Is that okay?
Sir, please discuss the question because the mock was not discussed earlier.
Yeah, you just try to cover the important topics with questions, so it will be helpful as per the quiz.
Okay, okay. All right then. So let's look at this first question. Okay, we were given x futures, and then the value we need to be predicting. Okay, so write a function that outputs the sign of x1 minus when a function that outputs sign of x1 minus 3 x1 minus 3x2, okay, is used as classification model. So you'll be using this is a predicted model. Okay, they're asking what is the resultant loss. All right. Okay, so this is the actual y values, and based on this x1 minus 3x2 sign, okay, we'll get a predicted y values, and then you can compute the resultant loss. Okay, I hope you are aware of this resultant loss for the classification model. Okay, so yeah, please
So,
try to
so
do
zero is
this.
considered to be positive now. The output zero
The output
sign.
0.
Sign of zero will
Yeah,
be
yeah, yeah, yeah. You can consider that as
Okay.
positive.
Okay, okay.
But I hope in this
Yes,
problem
the
we won't
third,
be
the
encountering that
third one we are
those
encountering that
things.
the third row, 3 comma 1.
The third one, 3
The
comma
third
1.
one, third
No,
problem.
no,
Yes,
no,
sir.
sir.
Question
Third.
one. Question one.
Okay, okay, 3 comma 1. Yeah, yeah, yeah.
So
Actually,
0.16.
looking at this, okay, that 0 will be considered as positive. Okay, try solving this. I'll give you guys like 2 minutes to solve this, and after that we'll be looking at the solution.
There's one thing. So, as per you, the level of questions for mock which we can see, like, is it similar to a quiz or it's like more or less? If you can give an idea.
The actual quiz questions, it could be like slightly more difficult than this. Okay, slightly more, but not like a big margin.
Achha, quiz will be a little bit more. Okay.
Yeah,
So
yeah.
pattern will be same, right?
But if you look at the graded assignment and then the practice assignment, right,
Hmm.
the the kind of questions you'll be getting the final quiz will be like similar to that. Okay.
Okay.
But
Okay.
sir, practice assignments and graded assignments were easier than the mock. I felt.
Okay. Then it's going to be like similar, right?
And
Okay,
sir,
okay, then that's good.
how many questions will be there?
You will be having 15 questions.
Okay.
Okay.
Okay. So I think the answer of first is
0.16.
it is maybe 0.16 or 1 by
Okay.
0.16. Yeah.
We'll check. So
And so one more thing, sir. In the quiz one mock this quiz, sir, it is not mentioned that we have to write the answer up to how many decimal places.
yeah, correct. So but that will be taken care in the final in the actual question. Okay. So there will
Okay.
be mentioning how many decimal points accuracy you should be mentioning. Okay.
Okay.
But generally, what will be my suggestion is, if you're not getting the exact value right, suppose let's say you got it as exactly point 0.1, okay, then you can enter point 0.1. But then if you got something like 0.133, something like that, okay, then you could enter the answer to like as many decimal accuracy as possible. Like try to enter it like up to 3 decimal accuracy if they haven't mentioned, okay, but I'm pretty sure that you have mentioned,
Okay. In the
okay,
quiz, the
all right.
it is mentioned that how many decimal place we have to write the answer.
Yeah,
Okay.
yeah,
Okay.
yeah.
No, but anyway, it is going to be a range thing, na? So it will be taken care of anyways, right?
Yeah, it's going to be range, but then see what's going to happen is, let's say you got the answer as 0.133, okay, and then
Mm-hmm.
and then you could be entering it as point 0.1, okay, you could be entering it as zero also, right,
Mm-hmm.
and some people can enter it as like
Right.
0.14. So the range which we give, depends upon the decimal accuracy we ask for. For suppose if we ask for like
Okay,
two
got
decimal
it.
accuracy,
Yeah, yeah.
then we
Understood.
yeah, then we'll assume like you'll give the answer as like 0.13 as such. Okay. So maybe we'll give from 0.13 to 0.14, something like that, or 0.12 to
Right.
0.14, something like that.
Okay.
Will
Thank you, sir.
okay. So the based on the decimal accuracy that has asked for, the range could change. Okay. So yes, that was that. And if you look at it, we'll try to solve this problem. X1 minus 3x2 for the first one, it's going to be positive, so plus 1, that's okay. There's no sign difference. 2 comma 2, it's going to be negative. For 2 comma 2, x1 minus 3x2, it's going to be negative. But the actual value is positive, okay. So for this there is a sign change. Here there is a loss. And for 3 comma 1, we will be getting 0. Yes, get this itself. Okay. For 3 comma 1, we'll be getting 0. 0 will be considered positive. Okay, for 4 comma 5, anyway, it's going to be for 4 comma 5, x1 minus 3x2. Yeah, it's going to be negative, and the actual y value is also negative, so there is no loss. 5 comma 4 2, the actual y value and then the predicted sign of x1 minus 3x2 is going to be same. Similarly for 6 comma 5, so thereby only one out of the 6 cases, okay, only one out of the 6 cases, the actual signs are not equal. Okay, so the loss is going to be equals to 1 by 6. All right, that's the first problem. And here too, right, here this 1 by 6, it's going to be somewhere like 0.166, right? So based on the decimal accuracy, if you ask for two decimals, you should be entering it as like 0.16, okay, or 0.172. Yeah, 0.17 is acceptable. Okay. Okay, all right.
Mm.
For dataset xa comma ya, they are given this values y equals to 1 to 4, because we are like, okay, we have like four observations here, and let the regression function be, they have given this regression or the model function. Okay, the mean squared error obtained while fitting this function will be, so the mean squared error will be nothing but the predicted value minus the actual value whole square. Okay, or actual value minus predicted value whole square. Either way, it's okay. Mean squared, it will be like the sum of those errors divided by n. So in our particular case, the n is equals to 4. So we will be dividing it by 4. Okay. We will. Should we solve this, or like the second question is all right, right? For everyone?
Yes,
Yes.
sir.
Okay. So we'll not solve this because it's just like computation from there. All right. Okay. Now for this probability model, probability model P of x equals to 1 by 5 is given, where x belongs to 0 to 5. Okay, is obtained by density estimation algorithm. Okay, for the data points, x1 equals 2.5, and x2 equals to 1, x3 equals 3, and x4 equals 4.5, and x5 equals 4.95. Okay, compute the negative likelihood loss of the model. They are asking you for the negative likelihood loss. So the the negative likelihood loss, the formula for that, it's going to be equals to 1 by n, okay, summation of minus log of p of xi. Okay, so what we could do is, since the p of xi it's same, we just note it down, write it down.
Can you please solve it, sir? Solve it, sir. In not.
Yeah. Okay, let me share it with everyone. Okay, right.
It's yeah.
So what we have is, we have here p of x equals to 1 by 5. Okay, for x belongs to 0 to 5. Okay, so the negative negative likelihood error, the negative likelihood loss, it's going to be equals to p of x. The this loss, it's going to be equals to 1 by n, okay, minus of summation of minus of log of p of xi. Okay, so here for us the x equals to 0 to 5, right? Okay, so 0,5. Okay, so here this is going to be the actually the area one. Okay, it's not for this particular case. We have like 1 by 5, right? And then we have for x1 equals 2.5 and x2 equals to 1, 3, 4.5 and 4.95. Since all these x values falls within the range of 0, 5. Okay, so what we have here is, here for x1, x2, x3, x4, x5. Okay, since all of this falls within the range, right? So the p of xi for all this, p of x1, p of x2, p of x3, p of x4, and p of x5, all of them, they are going to be equals to 1 by 5. So L loss will be equals to, since the n is 5 here, 1 by 5 summation of minus I equals to 1 to 5. Okay, minus log of p of xi. So p of xi is nothing but 1 by 5. Okay, they asked you to take the log as 10, right? If I'm correct. Yeah, use the log base 10 they have mentioned. So so we can take this and then try to solve for this. What's going to this? Okay, minus log of 1 by 5, you can consider it as like plus log of 5. Okay, log 5 to the base 10. Can someone tell me the value?
0.698.
Point
698.
0.98. This alone is 0.98, or the overall value you're saying?
No, log 5 value is base 10 is 0.698.
0.698.
0.69.
8.
1 second. Okay.
0.698.
Yeah, for log 5 base 10.
Okay, wait. Let me just do that. Yeah, so log 5 to the base 10, that's going to be equals to 0.698. Okay, So 0.698 divided by 5, you're going to get something like
Submission 5 then.
Also into 5, right?
what?
So
Because
we have
multiplied
submission.
by 5.
So it is divided by 5
Okay, okay,
because
okay,
we
sorry.
are
It is
adding
also
5 times now.
multiplied by 5, na sir?
Yeah, we are
Yes,
adding
Okay,
5
add
fine,
and
times.
be
okay, okay,
cancelled.
okay, okay, fine, fine, fine. Yeah, yeah. I did not do the summation, but yes. So yeah, it's going to come again to 0.16, 0.69 something. Okay, it's going to be the same one. So basically, it's going to be the log 5 to the base 10. The answer is going to be that. Okay, this I hope is clear. We'll move on to the
Yes.
next one. The encoder and decoder functions expressed as f of x equals to x1 minus x2 plus 0.5 x3, and f of x is given and g of u is given. Okay. So how do we do for this encoder decoder one? So we
So
have
the g times f of xi minus xi.
what?
There is a norm, right? Norm of.
So first we
Yes,
have
sir.
to calculate fx and gx and then find
First,
out the difference between
first what
gx
we'll
and
do
xi.
is we'll try to like we'll try to encode this and then like decode it. Okay. First based on x1, x2, x3, we'll try to encode it to some value of x. Okay. Based on that x value, again we'll try to decode it. Right. Correct.
Yes, sir.
Yeah, yes.
Let's try doing
Yes,
that.
sir.
Okay. So it's going to be like I'll do it for the first observation. For the first observation, minus 1, 1, minus 1. You substitute it here, you're going to get minus 1, minus of minus 1, plus 1. Okay. Plus 1, plus of 0.5 into minus 1. So it's going to be 2 minus 0.5, 1.5. Okay. So for f of x, it's going to be equals to 1.5.
Minus 2.5, sir.
Minus 2.
Minus 2.5.
Minus 1, okay. Right, yeah, minus 1. Yeah, okay. Yeah, minus 2.5. Okay. So we have here minus 2.5, and based on that, if you substitute that 2.5 here, okay, in this g of u, what you're going to get is you're going to get 0.3 into minus 2.5, which is going to be equals to 0.75. Okay.
Minus 0.75, sir.
Yeah, minus 0.75. Minus 0.75, and then this minus u, it's going to be equals to 0.25, and then the last one u value, it's going to be equals to minus 0.25. Sorry. It's not going to be minus 0.25, it's going to be minus 2.5, and then this second one, it's going to be equals to 2.5. Okay. Now what we have over here is, now that we know this f of g of f of x, g of f of x, right? It's going to be my 0.3 u minus u and then u. 0.3 u comma minus u comma u, since u is equals to minus 2.5. If you substitute this, what you're going to get is you're going to get minus 0.05 comma 2.5 comma minus 2.5. Okay, so these are g of f of x, but what is the actual one? The actual one is something like minus 1, 1, and then minus 1, right? Okay. So basically now we should be calculating the error that is the difference between the both. Okay. So what we have over here is we have here the g of f of x minus x, okay, whole square. The modulus one we should be doing. This is going to be the vector, right? Okay, this one minus 1 comma 1 comma minus 1, that's going to be a vector. So if you do this g of f of x minus x, so what you're going to get is you're going to get minus 0.75 minus of minus 1, it's going to be 0.25 comma 2.5 minus 1. Yeah, 2.5 minus 1, it's going to be equals to 1.5, and then minus 2.5 minus of minus 1, it's going to be minus 1.5. Okay. Now we need to find the length of this particular vector. What's going to be the length of this vector? It's going to be equals to 0.25 square plus 1.5 square plus 1.5 square. Okay. This is for the first one. Similarly, you need to be calculating the norm for the norm for the remaining ones. Okay. So when I mean like remaining ones, for the other points you should be calculating. Okay. You should be calculating the g of f of x minus the x. Okay. And then the norm value you should be calculating. The norm value it's just the length. Okay. Length square. And then you should be doing the mean of it. Okay. So just like I mentioned here. Okay. Here. This is going to be the length, and this anyway we are going to do square. So this also will be doing square. Okay. Clear? This problem.
Can you
So this is little lengthy, right?
Can you repeat?
This will be little bit lengthy, sir.
I'm sorry, I'm not able to hear you properly.
can you show the solution, sir? Because I have a doubt.
Sorry. Sorry, can you repeat the collisions?
Can you show the solution?
Yeah. So
I have a doubt.
yes.
Sir, in that fourth one, minus 1, 2, in that f of x, you got a 3, but somehow I got 1.
You're talking about this value?
Yeah, fx value.
Okay, this value we found that g of f of x minus x whole square, right? Then that's going to be equal to this one, right?
Not g of x, only f of x, I'm asking.
What's going to be f of x?
Yes, value. Because what
f of x is minus 2.5, right?
the value is 1, minus 1, 2. So if I put x
1, minus 1, 1 and the minus 1, yeah, that's going to be x. And then f of x value you're going to get as minus 2.5.
Sir, what I am trying to convey is only the fourth variable 1, minus 1, 2. Okay. If I put this value in fx, I got 1. Here I saw is 3.
It's correct. It's correct.
Correct. Okay.
Yeah. It
Yeah,
will
maybe
be.
okay, sir.
Hello, like not able.
Okay, sir. Okay, sir.
Is this okay? Like, see, what we do is we have this x vector, right? Based on this x vector, we'll be finding f of x, which will be a scalar. Okay. Based on the single value, we'll again be like decoding into a vector. Okay, into a vector of, like in this particular case, what we got is we got minus 0.75, 2.5, and then minus 2.5. Okay, so this is a predicted value, and then this is the actual value. Okay, by subtracting that you'll be getting the error. Okay, that error will be the error will be in the form of vector, right? So basically you should be finding the length of that particular vector whole square. Okay, like minus 0.75 minus of minus 1, it's going to be like 0.25 square plus 1.25 square plus 1.25 square. It's going to give you 1.25 square is 2.25 into 2, it's going to be 4.5. 4.5 plus 0.25 whole square, right? That's around like 0.0625. So that's why the overall value it's 4.56. This is for the first one, and similarly you should be doing it for the second ones too. Okay, once you completed all these errors, now you should be doing the mean of it. Okay, you should sum up that and then like divide it by number of observations. In this particular case, it's 5. Okay.
Okay, sir. Thank you.
We'll move on to the next one. The linear approximation one. The linear approximation determine the equation of tangent at x equals to 0.5 the tangent at x equals to 0.5 is nothing but the linear approximation. Okay, the linear approximation at x equals to 0.5, and using it, estimate the value of g of 1.5. Okay, so a function is e power minus x square plus 0.2x plus 2. The function is
0.2x.
0.2x plus 2. 0.2x plus 2. Okay, so at x equals to 0.5. Forget about at x equals to 0.5. Or suppose at x star at x star I am doing this linear approximation. Then the linear approximation of f of x, right, with respect to x star, it's going to be equals to f of x star plus, okay, x minus x star, okay, at the point multiplied by f dash of x star. Okay, so f dash of x, this is going to be like it's going to be like kind of like the slope value. Okay, these are the form of like y equals to mx plus c, right? Okay, so for x equals to 0.5, okay, the f of x, it's going to be equals to 2.5 power. They ask us to approximate it at x equals to 0.5, right? Yeah. Okay. So x equals to 0.5 minus 0.25 square, it's going to be minus 0.5 square, it's going to be minus 0.25 plus 0.2x. 0.2x, it's going to be equals to 0.2 into 0.5, it's going to be equals to 0.1. Okay, plus 2. It's going to be 2.5 e power 2.1 minus 0.25. That's going to be 1.75, 1.85. Okay. So this is going to be the f of x star or f of 0.5. Okay, f of 0.5 value is this, and then if you do the f dash of x, okay, f dash of x, it's going to be equals to 2.5 e power minus x square plus 0.2x plus 2 multiplied by, we should be differentiating this x square minus x square plus 0.2x plus 2, so that will give you minus 2x plus 0.2. Okay, and by substituting the value of x as minus 0.5, what you're going to get is you're going to get 2.5 e power minus same thing x square plus 0.2x plus 2 minus 2 minus 2x plus 0.2, it's minus 2x, it will be minus 2 into 0.5, it's going to be minus 1. Minus 1 plus 0.2, it's going to give you minus 0.8. Okay, so this value here in place of x, you should be substituting 0.5. Okay, so basically you're going to get the same value, so it's going to be 2.5 e power 1.85 multiplied with minus 0.8. Okay, so let's calculate that value. Okay, e power 1.85, that's equals to 6.359. 6.359 into 2.5, that's going to give you, this approximately equals 15.89. Could, like, you could take this as 899, you could take this as 15.9. Now the f dash of x, it's going to be equals to this value, which is just 15.9. 15.9 multiplied with minus 0.8. Which is going to give you minus 12.719. Okay. So this is your f dash of x. Now a linear approximation will be equals to linear approximation methods, right? Then it's going to be equals to 15.9 plus of x minus x star. Okay. X star is 0.5 multiplied by the f dash of x, it's what, 12.771. Okay, now they asked you to find 1.5, right? They asked you to find 1.5, then that's going to be equal to 15.9 plus 1.5 minus 0.5 multiplied by minus 12.71, right? This is going to be equals to approximately, it's going to be equals to 3.18. Clear? Let us check the answer. Yeah, it's equals to they are given the exact answer as 3.178, but the approximate value is 3.18. Okay. Here too they haven't given you the given you the range. I mean the decimal accuracy, right? So for now, what you could assume is that whatever value, right? You could enter, if it's like close to that, then you could assume that your answer is alright. Okay. In the final exam, anyhow, we will be asking you to enter it to up unto like 2 decimal accuracy and 3 decimal accuracy as such. Okay.
May I ask a question here once?
Yeah.
Just one. This x is equal to 0.5 is what you first use to get the linear approximation and then
Yeah.
substitute 1.5, is it?
Correct.
Okay. All right. Thank you.
So basically, that's what we do, right?
I remember the formula, but I am getting confused between which one to substitute, and that is where I'm making mistakes. That's the reason.
See, whenever you are here, they ask you to linear approximation at. Let us read the question and then like write down. Okay. Determine the equation of tangent at x equals 0.5. Okay. So basically, you need to do tangent at x equals 0.5. Okay. So basically, you're like you're finding the equation, okay, by using x star as 0.5. That is you're linearly approximating at x equals 0.5. Okay. So based on that equation, you get the value for 1.5.
Okay.
It's like let's say this is our graph. Okay. I'll draw some arbitrary graph. Okay. Okay, let's say like this is our graph. Okay, and then this is our 0.5. Actually, this should not be 0.5 because our slope is negative. Let's say like this is our 0.5. Okay, this is 0.5, and at this particular point, if you draw a tangent, it's going to be something like this. Okay, this is going to be this is going to be a tangent. Okay, and based on this, using this tangent, you'll be finding the value at like 1.5. Okay, at 1.5. So at point 5, you should be doing the linear approximation, and using that linear approximation, you should be finding the value at the point at 1.5. Okay.
Okay.
All right. So there are the next question. The directional derivative of f of x comma y equals to xy square plus 3x square at 1 comma 1 in the direction of unit vector along w. Here too the wording is important. In the direction of, okay, in the direction of means that, for suppose let's say we have vector v and then like we have vector u. What is the directional derivative of v in the direction of u? Okay, then what is that going to be? It's going to be v transpose u or v dot u. Okay, v dot u divided by u transpose u multiplied by u. Okay, so basically you're projecting v onto u. Okay, you're projecting v onto you. You're projecting v in the direction of you. Okay, if it has been like what is the directional derivative of u in the direction of v, then that's going to be opposite. Then that's going to be like v dot u. V dot u is going to be same divided by v transpose v multiplied by v. Okay,
Sorry, sir, could you repeat this?
Yes, I was going to ask the same. Thank you. Can you slow down and please once again?
Okay, so let me just write this down. Directional derivative of v in the direction of u, then that's going to be this one. Okay. If I ask you for directional derivative of u in the direction of v, then that's going to be this. Okay. This in the direction of right, in the direction of that determines what should be this value. Okay. If I ask you in the direction of u, then that's going to be this one. Okay. So since it's going to be u here, it should be u transpose u here. And then if I say in the direction of v, then it should be v dot u multiplied by v, okay, divided by v transpose v. Okay, clear? Hello.
So in the u in the direction of v will be
this one.
The outside factor will be v. Okay.
What u in the direction of v you're asking for?
Yeah.
Yeah, u in the direction of v, then that's going to be this one.
In the direction of v. Okay.
Okay. One simple point is, okay, now we have v here, we have u here. In the direction of u in the direction of v means u should be projected onto v. Okay, u should be projected onto v. so whatever resultant vector you get, that should be parallel to v. That should be parallel to v. When will it be parallel to v? When you multiply that by v.
Correct.
Okay. So if I ask you for a directional derivative of v in the direction of u, then whatever vector you're going to get, that should be parallel to u, because it should be in the direction of u, right? Okay. So that's the reason why we'll be having this u here. V dot u anyway it's going to be scalar. This is scalar. V dot u is scalar. U transpose u is scalar. Okay. This u value, u value that will show the direction, right? So in our particular problem here, they're asking for directional derivative of f of x comma y equals to x y square plus x square at 1 comma 1 in the direction of w. So in this particular problem, okay, see like at the particular point, what 1 comma 1. Okay. See, let's say like at this point of 1 comma 1, whatever direction we get, the vector in the direction of w, it should be like, okay, let's call this as v. Okay, then whatever vector you're going to get, it should be like parallel to w. So it should be v dot w divided by w transpose w multiplied by w. Okay, clear?
Yeah, and the scalar value that we get is the length of v projected.
Yeah. So and then if they are like perpendicular, right?
That's 0.
V and W are perpendicular, then this projected value, it's going to be a single point. Okay, and it does not have any length, so that's why V dot W will be 0. The projected value will be 0 if they are perpendicular. Okay.
Sir, we can also calculate using the directional derivative gradient form also, no?
Yeah.
If we can also.
Sir, can
Using
the gradient.
Gradient.
It's a gradient method. It's a gradient.
Okay, using the gradient matrix. That's what you're asking for.
Yes.
Okay.
Yes,
we can also
using
solve this.
direction derivative
Yeah.
definition.
Even that you can use. Okay, so that's going to be what? It's going to be w transpose divided by w transpose w multiplied by v, right? So in that particular case, then this is going to be the one, right? This is the one you're talking about, right?
No, sir.
No, first you find gradient of the f function f.
The gradient of f.
And
Yeah, that gradient should be there. The reason you're doing gradient is to get this vector. Is to get this vector. The gradient anyway will do. Okay, the gradient anyway will do. But
Sir,
what
sir,
I'm
can you
talking
please
about
see the
is,
solution, sir?
I'm just
Please.
talking about, let's say like you're given like two vectors, then how do you do it? In this particular case, to get the vector for 1, 1, you should be doing the gradient. That we'll do. Okay. xy square plus 3x square. For us, the f of x comma y, right, is xy square plus 3x square. Okay. So what's going to be the direction of this tangent? It's going to be dou by dou x, dou by dou y, right? Correct. So for this, we need to be doing the gradient. So the gradient for this dou by dou x, it's going to be equals to dou by dou x will be equals to
Y square plus 6x.
y square plus 6x. Okay. And dou by dou y, it's going to be equals to 2xy. Okay. And then if you substitute the point 1, 1, okay, 1, 1, this is going to be equals to 1 plus 6, 7, and this is going to be equals to 2. So our vector, it's going to be what? 7, 2. Okay. 7, 2, and then they asked in the direction of minus 1, 1, right?
We have to first make it in a unit vector, sir.
What?
So we have to make it a unit vector, sir. Minus 1.
See, the 7, 2, we should not be making a unit vector, but the other
No,
one,
sir. Along the vector, sir. Yes, sir.
okay. So even if you did not do it, even if you do not make it as unit vector, but if you use this formula, then it work out. Okay.
Okay, sir.
Is this clear?
So it is same as a projection.
Yes, sir.
What?
So is it same as a projection of a vector?
Yeah. So basically, we are doing projection only. We are doing nothing else. We are doing the projection only. Since they ask you to find the
the projection and the direction derivative are the same things.
The projection and
directional derivative.
Yeah, it's same. So here actually they're asking you for the length of the projected the projected vector. Okay. Sorry. The directional derivative and the projection, they are not same. Okay. The directional derivative is the tangent is the tangent at that particular point. The directional derivative, you'll be defining it for a point and a function. Okay. So for example, here we have done this, right? We are talking about this linear approximation, right? Remember, we are talking about this linear approximation, right? Right? When you are doing the linear approximation, what did you do? You found this f dash of x, no? F dash of x or gradient f of x. Gradient f of x, if it has been for higher order, this f dash of x and then the gradient f of x, that's going to be the directional derivative. It's going to give you the direction. The slope value, it's going to give you the direction. Okay, that is the directional derivative. All right. Clear? But then the projection is different.
Okay, sir.
For projection of one vector onto another, you need like two vectors, right, to find the projection of one vector onto another. But for the directional derivative, you need a point and a function to find the directional derivative. Directional derivative is nothing but the tangent equation. Okay. Clear? What I'm trying to say?
Yes, sir. Clear.
Okay. In this particular case, okay, what you are asking for is like you are saying that we should be converting this minus 1, 1 to unit vector, right? Okay. The reason right now we are just asking for they're just asking for the length. They are not asking you for the vector. Okay. So for you to simply do that, all you need is you need like v dot w. Okay, v dot w, and this w should be like w should be unit vector. This w should be unit vector. So that is why you'll convert this minus 1, 1 to unit vector. Minus 1, 1 length is root 2. So you just divide it by that. The unit vector in the direction of minus 1, 1 will be equals to minus 1 by root 2 and then 1 by root 2. And what did we get this v value? V value is 7, 2, right? So it's going to be it's going to be equals to minus 7 by root 2 plus 1 by root 2, which is going to be equals to minus 6 by root 2. Okay, minus 3 root 2. This is going to be the directional derivative value. Okay,
I think that it was 7,2, so it should be
what?
7,2. Then it should be
Yeah,
minus
7
7.
comma 2. Yeah,
So we should minus 7 by root 2 plus 2 by root 2.
yeah, like I've done it directly there because we have here 7 comma 2, right? 7 comma 2 vector dot minus 1 by root 2 minus 1 by root 2. What it's going to be? It's going to be
Sir, there should be, it should be plus 2 by root 2.
okay.
Yes, sir.
Yes.
Yeah, yeah. This is 7 comma 2, right? Yeah, it should be plus 2 by root 2, and this will be minus 5 by root 2. Okay, minus 5 by root 2. Okay.
Also, sir, we got the unit vector W just by dividing the vector by its norm, correct?
Yeah, yeah.
Okay, sir. Thank you.
That's how you get the unit vector. It should be of unit length, right? And then norm will give you the length. So
Yeah, sir. Got it.
divide a vector by length, you'll get the unit vector. Okay. Yeah, we'll move on to the next problem. They are given you the function g of x comma y. Okay, at 2 comma 1, they are asking you to find the first element gradient, first element of the gradient. Okay, the gradient is what? Dou f by dou x and dou f by dou y, right? Okay, in this particular case, it's g. Okay, square root of 2x square minus y cube. G of x comma y is square root of 2x square minus y cube. And then the gradient, it's going to be gradient of g, it's going to be dou g by dou x and then dou g by dou y at a particular point of 2 comma 1. First we'll find this dou g by dou x and dou g by dou y. Dou g by dou x, it's going to be equals to this one square root of it is of the form of square root of x, right? So it's going to be 1 by 2 by 2x square minus y cube multiplied by this 2x square. It should be 2x square minus y cube. It should be partially derivative with respect to x. Sorry. So that's going to be equals to 4x.
4x.
Okay. And then similarly, you should be doing dou g by dou y. Again, it's going to be the same one. The denominator is going to be same. 2x square minus y cube. And then the numerator here, since you are doing partial derivative with respect to y, it's going to be equals to minus 3y square. Okay. All right. So now if you substitute this value of 2 comma 1, yeah, 2 comma 1, what you're going to get? You're going to get, first let us look at the denominator. It's going to be 2 into 2 square 8. Yeah. 2 into 2 square 8. 8 minus 1 7. So square root 7. 4 2 is 8. 8 divided by, this is going to be equals to 8 divided by 2 root 7. Okay. And then the second part, it's going to be equals to, this is going to be minus 3 by 2 root 7. Okay. So you just substitute that, you just compute that value. Okay. So that's 7 root 2, 7. Yeah, you can just substitute that, then you'll be getting the answer. Okay. So basically, the first element is going to be this 4 by root 7, and the second element is going to be minus 3 by 2 root 7. Just check that. Let's check whether we got it correct. Just the computation part. Yeah, we got it correct. Okay. This should be actually, okay, yeah, correct. So 4x by 2, they are cancelled. Yeah, correct. So 7 and 8 they are same. So the 7th question they ask for first element and 8th question they ask for second element. Okay. Let us look at the ninth problem. For the ninth problem, a function f of x comma y is x square plus 2x y cube is approximated linearly in the neighborhood of 2 comma minus 2. So it is just going to be a linear approximation. Using the approximation, find the value of f of 2 comma 3 comma minus 2.2. This problem is same as this one. This problem is same as the fifth one, except that here it is of like multiple variable. Okay. Since you're having this multiple variable one, you should be using the gradient. Okay. When you're having higher power, right, then the linear approximation, a single dimension one, a single dimension, it is of f of x star plus x minus x star multiplied by f dash of x star, right? For multiple dimension, it is again f of x star, but here the x star is a vector plus x minus x star transpose multiplied by gradient of f of x. Okay, so this is going to be for the higher order, higher dimensions one. So in a particular case, it's x square plus 2x y cube, x square plus 2x y cube, and then f of x is for x comma y is x square plus 2x y cube, and then you should be linearly approximating at 2 comma minus 2. Using this, we need to get the value at 2.3 comma minus 2.2, right? Yep. Okay. Okay. So first we need to get this gradient, right? So let's do that. The gradient, it's going to be equal to dou by dou x and dou by dou y. So this will be equals to x square, right? X square, that's going to be equal to 2x plus 2x y cube, that's going to be equal to 2y cube. And then the dou by dou y, this will be 0 and this will be equals to 6xy square. So let's substitute this 2 comma minus 2. Then that's going to be 2 into minus 2 minus 4. Minus 4 multiplied by 2 into minus 2 cube is minus 8, minus 16. Minus 16 plus 4, it's going to be minus 4. And then this one, it's going to be 16 2 into 2 square. So 8 6 are 48. Am I correct? This one? This? Okay. I hope it's okay. Then later we should be doing this x minus x star, right? X is x star is 2 minus 2, and then this x is 2.3 minus 2.2. Then x minus x star is going to be equals to 0.3 minus 0.2. Okay. So here we substitute this here, and we need to find the f of x star. Okay. F of x star is going to be x square. It's 2 square 4 plus 2x y cube. It will be 2 into 2 into minus 2 cube. So it will be 8. 8 4s are 32, right? Yeah. It's going to be minus 32. 4 minus 32, that's going to be equals to minus 28. Okay. So f of 2 comma 2 is minus 28. So our linear approximation for x comma y, right? It's going to be equals to f of 2 comma 2 plus this x minus x star transpose multiplied by gradient of f of x. Okay. So f of 2 comma 2 is minus 28. So that's going to be minus 28 plus x minus x star is this 0.3 minus 0.2. We should be doing the we should be doing the transpose for it. So it's going to be 0.3 minus 0.2 multiplied by the gradient f of x. That's going to be minus 12 and 48, right? 12 and 48. Now this will be equals to minus 28. 0.3 into minus 12, well, 3 is 36, minus 3.6. And then 48 2s are 96, yeah, minus 9.6. So this is going to be equals to what? 11 point, sorry, 12.9 plus, plus 28 minus 41.9. Let's check if you got the correct answer. Minus 41.2. You got is minus
Sir, this is minus 41.2
what?
summation. Summation is, sir, it is 41.2.
What?
That's
What?
6. So
41
that's
point?
41.2.
41.9 only, right? The summation?
No,
No,
sir,
it
2.
is minus
2.
41.2.
Sir,
Okay,
6
okay,
and 6.
okay. Sorry, sorry,
Yeah,
sorry. Yeah, 6, 6, 12. Okay.
yeah, 12, sir.
Minus, yeah, okay. Minus 41.2. Yeah, okay. Okay, so the ninth question is clear. Ninth
Yes, sir.
question is similar to the fifth one, except that here we are using the higher order ones. The dominant eigenvalue of the matrix. First of all, the dominant eigenvalue is nothing but the highest eigenvalue. So for this particular problem, right, 2320. For this particular matrix, the eigenvalues will be equal to 232. Okay, so the matrix is 20204 030 and then 012. Okay, so just by observation, I was just like able to find this that if you substitute, I mean, if you take lambda equals 2, right, then you'll get a minus lambda determinant as 0. Because you could check this, okay? A minus 2i, what you'll get is, you'll get it as 004 and then 010 010. Okay. So and then the gradient for this, it will be equal to 0. You could check this. The gradient for this is 0.
Yes.
So 2 is 1 lambda value, and then similarly the 3 is also 1 lambda value. Okay. 3 is also the second one, because if we do this a minus 3i for this, what you're going to get is you're going to get minus 1 0 4 and then 0 0 0. If you're having the 0 0 0, which basically means the determinant for that will be equal to 0. Okay, if I going to have any 0 column or 0 row, right, then the determinant will be 0. Okay, so lambda equals to 3 and then lambda equals to 2 comma 2. Okay, so basically the dominant eigenvalue will be equals to 3. Okay.
So I'm having a query regarding this. The maximum value meaning the only the magnitude, right? Had it been like minus 3, 2, 2, still it could have been minus 3, right? The
No,
dominant one.
our eigenvalues are 3 and 2. It's not minus
3.
3.
I'm just asking in case we get certain something like that.
Okay, okay.
Minus 3,
If I asked about minus 3 and minus 2, then it's going to be minus 2.
yeah, minus 3 and 2 suppose I'm having. So what will be the dominant one?
Minus 3 and
2.
minus 3 and 2, then that's going to be 2.
Acha, okay. It's not the
Sir,
magnitude.
when I asked Vishal sir yesterday, he said
Exactly.
that it's the absolute value. So even in
That's why
that
I
case, it would
asked.
be minus 3.
Absolute values. Okay, you just check that. Okay, I'll confirm.
Okay.
1 second.
Sir, how do we know that 2 is going to repeat 2 times here? I mean,
See, we should be having three eigenvalues for this.
We can calculate the determinant of A minus lambda I, so you will get two value, same value of two times.
Let me just check that the dominant eigenvalue. Okay. Yeah. It's a absolute value. Correct. Okay. So if it has been like -3 and 2, then the dominant eigenvalue will be this -3.
Okay, thank you, sir.
Okay.
So in that case, we need to write the absolute value 3 or minus 3 we have to write as answer.
Yeah, the whatever eigenvalues you get, no, you should be checking for the absolute value, and then whichever eigenvalue has the maximum absolute value, then that's going to be the dominant eigenvalue. Okay.
So we have to write the absolute value. If it is
Yeah,
-3, then we have
yeah,
to
yeah.
write 3.
Correct.
Okay.
So we have to write 3, or we have to consider it as a
No, no, you
absolute
should be
value
writing
and write
-3.
-3.
You should be
Yeah,
writing -3
yeah,
because
We have to write
3 will
-3.
not be the eigenvalue, right? -3 will be the eigenvalue. So
Okay.
right. Thank you, sir.
okay. Now
I have
the
-3 and -8.
-3 and -8, then that's going to be -8 because for -8 the absolute value is highest, right? For -8 the absolute value is 8.
Okay.
Okay. Okay. So let us do. We will take a short break. Okay, and then after that we'll continue. We'll take a break for 5 minutes and then we'll continue. Okay.
Okay, sir.
Yes, sir, yes.
Thanks.
Hi, can anyone explain why did we get like we are going to get three values, three eigenvalues that I understood, but how did the value 2 repeat two times? How do we get that?
For that, you have to calculate A minus lambda I.
Determinant of A minus lambda I, put it equal to 0.
Yeah.
Then you can see after. Yeah, continue, bro. Nikhil, did you understand?
A minus lambda I, it will give
Determinant of
me
A.
three values, right?
Yes. Let me get three values.
And we hit and trial and we somehow get one value and then
No hidden trial actually. We have to equate the determinant of A minus lambda I to 0 and then solve it to get the values of lambdas.
yeah, actually,
Are you
yeah.
asking for lambda cube expression?
Yeah, yes.
Yeah,
Once it
hit
is
and
in
run, you
cube,
have to
then
find the yes. First value you have to try for hit and run to get. Then you can divide with that expression. If one is your
Okay, they're talking about
hit and
lambda.
run value, you can divide the leftover expression with
okay,
lambda
got
minus
it.
1.
Long division type of thing, right?
Yes, what we did in maths
Yes,
1.
yeah.
Lambda
Thank
minus 1 and you will do
Yes,
long division.
yes. Thank you.
Oh, do we guys have any WhatsApp groups?
Could you repeat?
Yeah,
Do
there are
we have
many.
any WhatsApp group?
Yeah. Did you not edit in WhatsApp group?
No.
I think the lambda term, we can split that lambda term, and then we can take out lambda common and factorize that quadratic. And the last two terms we will get a common factor that also we can solve it.
Yes.
Krishna, can you share the invite link of WhatsApp link of the group?
Yeah. Wait. I'm doing.
And we are not getting any formulas for this quiz, right?
Yeah, you not get the formula sheet, Nikhil.
Okay, thank you. But why is there a change in the policy?
Okay, so let us continue the discussion. All right. Let me share my screen. They're asking you for to find the length of parameter obtained by projecting U onto V. Okay. So how do you do this, Randwan? Any idea?
We take U minus the projection vector.
Yeah, that's one way. And then they just ask me to find the
Length of the vector.
length, right? So
So then the magnitude of that vector.
yeah. So first of all, we have this. Let's say like this is the projection vector, and then this is the loss vector. That should be equals to U, right? Yeah, it should be equals to U in this particular case. Okay. So and we know that the projection vector and the loss vector, they both will be perpendicular to each other. Correct? So the modulus of U whole square, it will be equals to modulus of P whole square plus modulus of L whole square. So basically, if we can directly know the length of this vector because U is already given to us. We can find the length of the projection vector, and based on that, we can find the length of the loss vector. Okay, without us having to find the actual projection vector. Okay, we have U equals to minus 1, 4, 2, 1, 2, 3. U is equals to minus 1, 4, 2, and then V is equals to 1, 2, 3, right? Okay, so what's going to be the length of projection of U onto V? What's going to be this modulus of V whole square? It's going to be U dot V, V unit vector, right? It should be what? U dot V by mod V.
Yes.
This is the one, right? Correct?
Yes, sir.
Right, so what is going to be U dot V? U dot V is going to be minus 1 into 1 plus 4 into 2 plus 3 into 2. It's going to be 8 plus 6, 8 plus 6 plus 14, 14 minus 1, 13. 13 divided by 1 square plus 2 square plus 3 square. 1 square plus 2 square plus 3 square, that's going to be 1 plus 4 plus 9. It's going to be square root 14. Okay. So this is going to be this is actually U dot V by mod V. The square of it, this is going to be mod P, okay? And then if you ask me for the mod P whole square, right, then we need to do the square for this. Okay. Now what about the length of U? Let's just mod V whole square, that's going to be equals to 1 square plus 4 square plus 2 square.
21.
Okay. That is 1 plus 16
21.
plus 4, which is equals to what? 21. Okay. All right. So this 21 will be equals to this mod p whole square, which is nothing but 13 square divided by 14 plus model whole square. Okay, how we can find this? First thing first, we'll do the 13 square divided by 14. That's around equals to 12. Okay, minus 21. Okay, minus 21. Minus 21 minus 12, that's going to be around 9. Okay, so the length of this L now, it will be the modulus of L whole square, it's going to be approximately equals to 9, and then L will be the length of the norm of L now, it's going to be equals to 3. Okay, the square root of it. All right, let's check this. Yeah, no, not this one. No, it's 13 by 14. Okay. They they just given you in the answer, right? They just mentioned this value. Okay, but ideally they should be giving you the length of that particular one. Let's check the answer. Okay, they have given from 2.5 to 3.5. Yeah, so our answer is 3. Yeah, that's correct. Okay. Is this clear?
Sir, could you explain it once again, please?
You want me to explain this
Yes,
once again?
sir.
Yeah.
Okay.
Sir,
So now I'll
because
try to explain this with the graph.
finding
Okay, so
we have to calculate E is equal to B minus P. So is there any alternative method to calculating the error vector?
yeah, I just mentioned the alternate way. So I did not do it in the normal way. Okay. Normally, what we do is we have u is equals to the error plus error vector plus projection vector, right? So the error vector will be equals to u minus p. Okay, you do this and then you solve for it. But what I have mentioned is, suppose we have this is a u, okay, and then this is v. Okay, this is v. So this is going to be my projection vector. Okay, until here this is going to be my projection vector. Okay, this is going to be the angle 90, and this is going to be my error vector, right? This is my actual vector u. This is my actual vector u, and this is my projection vector p. Projection of u onto p, u onto v. Okay, I am representing that by p. Okay, and then this is the error. Okay, this dotted line, that is the error, right? These two are like perpendicular, right? Right, by this Pythagoras rule, what do you know? We know that modulus of p whole square plus modulus of p whole square is equals to the norm the length of p whole square plus length of p whole square should be equals to length of p whole square, right? And this is the projection vector length plus error vector length should be equals to the actual vector length. Okay, so we can find the projection vector length by doing this u dot v divided by the length of v. Okay, so using that you can find the length of p. Okay, the length of u anyway you can directly find using this since the vector is already given to you minus 1 4 2, you can directly find the length of it. Okay, so you know this you can find this. All right, so through this way, you need not find you need not have to look at the what is a projection vector and what is the array vector. You need not do all that. You can directly solve for this. Okay. Clear?
Yes,
or,
sir. Yes.
or let's say like you want to do it the routine way, then what you can do is you can do this u transpose v divided by v transpose v multiplied by v. Okay, this you can find, this is going to be the projection vector. Okay, then you need to do this u minus p, you need to find u minus p will give you the error vector. Okay, now you can find the length of this vector by doing this. Okay, you can do it in either way. All right, clear? First of all,
Yes, sir. Yes. Clear.
okay.
I have a question here. Once we get the error vector,
Huh?
it's going to have three components to it, right?
Yeah.
So how do I enter three components there for the answer? I think the expected value is only one.
They've asked for the length of the error vector. We'll have to
They're asking
calculate
for
the
Length
length.
norm.
for the sorry. My
Yeah,
mistake.
we'll have to calculate the length.
Length. Okay.
Okay, this look at this problem. The vector x a comma b has dot products x dot r equals to 1 and x dot s equals 0. They given r and s. This is a simple problem. 2 comma minus 1 and then minus 1 comma 2, right? X dot r equals to 1 and then x dot s equals 0. R is equals to 2 comma minus 1 and then s is equals to minus 1 comma 2. Okay, so let this x be equals to a comma b. Okay, ab. Then what's going to be this x dot r? X dot r, it's going to be equals to 2a minus b. That is given as 1. Okay, and then this x dot s will be equals to minus a plus 2b, which is given as 0. Okay, which basically implies a is equals to 2b, and then I could substitute this here, which gives me 4a minus b equals to 1. Sorry, 4b minus b equals to 1. 3b is equals to 1, and then b is equals to 1 by 3, and then a is equals to a is equals to 2 by 3. Okay, so is this clear?
Yes, sir.
Like we just did the dot
Yes,
product.
sir.
There's new there. Okay. So the value of a will be equal to 2 by 3, which is like 0.66, and then the value of b is 1 by 3, 0.33 something. Okay. Now this one, consider line with a zero slope and y-intercept. The sum of the squared residuals obtained when this line is used to fit the following data set. This is nothing but the error they
Loss.
are asking for. Okay, you could kind of think of it like okay, for all of this, no, the predicted value they are fitted using a line, right? Using a line with zero slope and y-intercept 2. So no matter what the value of x is, the predicted value will always be equal to 2. Okay, so so that so the y predicted value, that's going to be will always be equal to 2, right? And they're asking you for the sum of squared residuals. The squared residual is nothing but the expected value minus the actual value. Actual value. Okay, that square you should be doing. Okay, so it will be equals to, since our predicted value is always 2, what you get is you get 2 minus 2 whole square plus 4 minus 2 whole square plus 1 minus 2 whole square plus 3 minus 2 whole square. Okay, so basically it's going to be just that. All right.
So can you write?
What?
Yes, sir. Is it same to calculate the error with respect to line by?
It's same to calculate the error, except that they did not ask you for the mean of the sum, right? So you should just be doing the sum of the errors you should be doing. You should not be dividing it by n. Okay.
Okay, sir.
I can understand. Can you just
What?
show it? Can you just show in the
Okay. We have it here. Okay, we have a point here 1 comma 2. Okay, 1 comma 2, 2 comma 4, and then 3 comma 1, 4 comma 3, right? but our predicted but our line we have fitted, right? That is a line with zero slope, and then y equals 2. Okay, so no matter what the value of x is, our y value will always be equal to 2, right? Okay, so the residuals, it's going to be the deviation from the line, right? The deviation from the from the line we have fitted, right? So for the 1 comma 2, since our y value and then this 2 value both are same, there's not going to be any residue here. But for the 2 comma 4, you are going to have a residue of 2. Okay, so the square residue, that's going to be equal to 2 square. Similarly for 3 comma 1, also the difference is going to be 1. Okay, so you're going to do 1 square. For 4 comma 3, also the since 3 minus 2 is 1, the difference is again going to be 1. Okay, you're going to do 1 square. So it will be 2 square plus 1 square plus 1 square. Okay, that's going to give you the sum of the square residue. All right.
Okay.
Okay. Okay. The matrix A is reduced to its triangular echelon form. The number of free variables is. We'll try to do this. So what we have is we have this 1, 2, 2. We have a matrix 1, 2, 2, 1, 2, 2, 4, 6.
Not able to hear you. Is it only I who is facing the problem?
What?
Yeah.
You want? I'm not able to hear you. Did
Sir,
you?
he wasn't able to hear you. So he asked if it
Okay,
was a
you are not able
problem
to
with
hear
him
me.
or everyone
One
else.
second, 1 second.
Is it
No, sir.
Is it okay now?
Yeah, I'll do that.
Okay. Now?
Yes, sir.
Okay. 0, 0, 1, 2, 3. Okay. Now this we'll try to reduce it to this triangular equivalent form. Okay, that's nothing but the normal way we do, right? The normal, like we try to reduce this bottom rows to 0. Okay, then should be equals to, you could do this x2 minus x1, so that's going to be equals to 1, 2, 2, 4, 6, and then this is going to be 0. 2 minus 2 is 0. 3 minus 2 will be equals to 1. 6 minus 4 is 2. Yeah, and then 9 minus 6 is 3. Okay, now we are going to have 0, 0, 1, 2, 3. Okay, what you have is, you have here, now the final form is 1, 2, 2, 4, 6, 0, 0, 1, 3. Okay, so basically you have like just 2. Okay, basically you have like these two are like same. Okay, basically you have like only two
Two
variables. Okay,
fixed
the
variables.
rank is 2. Huh?
So there are two fixed variables and
Yeah,
three
yeah, yeah.
free variables.
You are like rank 2, which means that the fixed variables are 2, and then the free variables, it's going to be the number of columns 5 minus 2, 3. Okay, all right. Yeah. Okay. So that is the.
Sir, it is not live on YouTube, sir, I think.
Yeah, I know. No. So there was some
You
error.
are, you are doing local recording? You are doing local
Yeah, I'm
recording?
doing the recording. I'm doing the local recording.
Kindly upload it, sir. Huh?
Yeah. Okay. Okay. So that's all the mock we have. So any other questions you have?
Sir, could you please explain the mocks question 14 once again? I didn't quite understand it.
I have a
Okay.
few questions probably after.
The question 14.
Yes, sir.
Okay. So we have here the points. 1, 2, 3, 4. 1, 2, 3, 4. For this, the values are 2, 4, 1, 3. So for 1, it's 1, 2. Okay, this is the first point, and then for 2, it's 2, it's 4. 2, it's 4. And then okay, for 3, it's 1. Okay. For 4, it's 3. Okay, so these are the 4 points we have. Okay, these are the 4 points we have. So basically, to they are trying to fit these 4 points into a line. Okay, so the line they have mentioned is this one. Okay, this is the line. The line is y is equal to
Y equal to 2. Yes, sir.
y equals 2 is the line. So the residue is nothing but whatever points we have, right? The error with respect to the line we have tried to fit, right? So for this particular point 1, 2, right? The error is 0 because that
It
line
lies on the
falls
line y
on the
equal
line,
to 2. Yes,
huh?
sir.
Right? For 2, 4, the residue will be this. The residue will be this one. Okay, the length it's going to be 2.
Yes, sir.
For 3,
It's going to be
1.
1. Got it, sir.
Okay. For 3, 1, it's going to be equals to 1. And for 4, 3, it's again going to be equals to 1, right?
Right, sir.
The squared residue will be equal to 2 square, 1 square,
Right,
and 1
sir. Right,
square.
sir. Got it.
Right? For this anyway, it's going to be 0, 0 square. So the sum of square.
So in the end, do we need to divide by the number of points, sir? Like 1/4 in this case?
No. You should not be doing. They just ask you to find the squared residue. They did not ask you to do the mean square residue. So
Okay. So when they ask mean square, then only we have to divide by the
yeah,
numbers,
yeah.
right? Number of points. Okay, sir. Thank you.
Other questions?
Yeah, I have a question. I'm trying to paste it in the chat window, the image.
Yeah, please do it.
Uh-oh. It's not coming through.
I think it
Just maybe.
in a chat.
I can't do it in the chat. Okay, then can I go ahead and share my screen if it's okay with you?
Yes, sure.
This is again from the mock exam that I was just doing. And I have a few questions which I was not able to answer. So let me know once you see the screen, please. Are you able to see the screen?
Yes.
Yeah. I'm quite not able to solve this one about the continuity. This is one question and this is the next one. These are the two I would really need your help with.
Okay. Can you go to first problem?
Yeah.
Okay, find the value of a such that f of x is continuous at x equals to 0. Square root of 1 plus x minus square root of 1 minus x divided by x. Okay. Okay. First of all, at x equals 0, what's the value of f of x?
X is equal
X
to 0,
equals
it
to
is
minus
1.
1, right?
Sorry, -1. No, wait a minute.
Minus 1, right?
-1.
Okay. Let me just note that down. Okay. After that,
Yeah.
stop sharing so that I'll do.
Yeah.
Okay. So just a moment. I'll note that. I'll note that. Okay.
Sure.
Or else you can stop sharing and then like just tell me what the function is. Okay. You can stop sharing. It's all this. Please stop
Okay.
sharing.
Right. Yeah.
Okay. Yeah.
It is.
Yeah, I'll share the screen once.
Yes, please.
Okay.
So f of x.
To be continuous at x equals 0, what are the cases? Limit extends to 0 plus f of x should be equals to
f of
limit
x
x tends to 0 minus
0 minus
f
is
of x
equal
should be
to
equals to
finally at x is equal to 0.
f of 0, right? And
Right.
we know that f of 0 is minus 1.
Yeah.
Okay. So what about the limit x tends to 0 minus? What's going to be the function here for 0 minus?
Square root of 1 plus ax minus square root of 1 minus ax divided by x.
X, right? Okay.
Yeah.
And then limit x tends to 0 plus it's what is it?
2x plus 1 by
2x plus 1
x
divided
minus
by
1. X minus 1.
x minus 1. This anyway it's going to be
It's
equals to
got
minus
minus 1. Yeah.
1. This around we need to solve.
Correct.
So this of the form, if you directly substitute this as like x equals 0, right? What you're going to get is you're going to get it's a form 0 by 0.
Yep.
Okay, if you have this of the form 0 by 0, then the way to do it is
L'Hopital rule.
L'Hopital's rule.
what?
By L'Hopital rule.
Yeah, you differentiate the numerator and then you differentiate the denominator, right?
Yeah.
Yes, sir.
Okay, so let's do that. We'll differentiate the numerator first. 1 plus ax, if you differentiate it, it's going to be 1 by 2.
1 by 2 into square
1
root
plus
of
ax into a.
A.
Okay? And if you differentiate this minus of 1 minus 1 minus 1, then it's going to be minus of a by 2 into root over 1 plus x. So it's going to be 2a by 2 root over 1
No,
plus
it won't
x.
be 2a because the denominator, sorry, that one is 1 minus ax, so you cannot have the same denominator. One is 1 plus ax, other is 1 minus ax. So even if you were to differentiate.
So see this if you differentiate now, what you're going to get is you're going to get minus a by 2 into root over. Okay,
1
so
minus
yeah,
a.
correct. This is not the one. Okay. It's going to be a by 2 into root over
1 plus ax plus
a by 2 into root over 1 minus
1.
x.
Yeah.
This is what you're trying to say, right?
Correct. That's equal to minus 1.
And you differentiate this with respect to
That's going to be
x, so
1.
that's going to be equals to 1.
1, yeah.
Now if we substitute the value of x equals 0, right? What you're going to get? You're going to get half a plus half a. It's going to be equals to a, right?
Yeah.
Correct.
A is equal to minus 1.
Now this a should be equals to minus 1.
Okay. Sorry, that's too silly actually. Yeah, somewhere I got stuck in the L'Hopital's rule and then I missed that one.
That's all right.
That is one, and yeah, there is one more question on the gradient itself. The steepest ascent is being asked. The function is f of xy is equal to 41 minus 4x square minus y square whole under root.
This one?
Yeah, at 2, 3.
At?
2, 3.
Okay.
So in the gradient,
this one, I'm not sure if the steepest it isn't right.
it's rate. Sorry, I misquoted the question. Give the maximum rate of change of the function. I will show you the question if it's okay with you.
The maximum rate of change of the function at 2, 3.
2, 3.
That's the norm of the gradient, no?
Yes. Norm of the gradient.
What?
The maximum
Norm of
rate of
the
change
gradient.
is norm of the gradient. So we need to find the gradient vector, then calculate its norm. And that's the maximum rate of change.
Minimum is negative norm. Maximum is positive norm.
Hello?
Gradient vector at 2, 3 and find its length.
Okay, can you just share the entire problem, please?
On the screen?
Yeah.
Okay, just a minute. I will go directly to the problem itself, so it's going to be easy. Okay. Are you able to see my screen?
Yes, yes.
Yeah, so this is the problem. We are supposed to find, like, this is how the problem goes.
We compute the
Complete the
equation
equation.
in approximation. That is okay. That can be done.
This part is done. A and B and C is done. Now the
Okay.
last part of the question is essentially give the maximum rate of change of the function at 2, 3.
The maximum rate of change of the function at 2, 3. Maximum rate of change.
Raviji, did you got the gradient function? Gradient?
Yeah, the gradient function is
Find it norms. Find
minus
it
2
norms.
and minus points. I'm just computing that actually as
Yeah,
I'm.
find its norm. Square root of.
Yeah, x square
So is this a okay? This is a quiz one, right?
2.13. Yeah, the answer is working. Yeah, it comes.
If
It
asked
contains
the
the norm
minimum
of
rate of change, you have to take the negative sign. That's it.
yeah. It like basically they ask it's equal to the norm of the gradient, right?
Yeah, yeah. That's what I was having trouble with as to how to evaluate is what I got the gradient or gradient vector also. After that, what to do is what I was
You just need
getting
to
my head
find
about.
the length of that vector, right?
Yeah, yeah, yeah. Now I got it. Now I got it.
Okay. Okay. Yeah. Okay. Fine. Then stop sharing.
So those are the.
Sir, I had 3 questions from previous term quiz.
Okay.
So should I share my screen or?
Yeah. 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 Please share
Okay,
it.
sir. So this is the first question, number 125.
Okay. What will be the directional derivative of f of x, z at 1, 1, in direction of a similar problem to this we have discussed it already.
Yes, sir, but my answer didn't match with what is given here.
Okay. So you have here x square y cube minus 4x z, right? Okay, just 1 second. I just note it down. X square y cube minus 4x z then minus 1 to 0. Okay, this is first problem. And what about second one?
Yes, sir. Just a second. Question number 127. Here.
This one?
Yes, sir.
This you're not going to get. This you're not able to get the answer.
No, sir. I got it 0.5 something, and this is around double of what.
0.27 answer.
Yeah,
I got
looks like
0.5.
she got the correct answer. 0.27.
27. 2764.
You can just check that again. Okay.
All right, sir. I'll try to redo it.
Okay.
And
What about third one?
this is the last one. Question 136. Yeah.
Okay. Consider the data set with the input x and y as follows. The given data set Raj wants to compute a least square approximation.
This is as similar as our PA and GA, this question.
Least square approximation that best fits which is the following correct equation.
Similar question, we have one question in PA and one question in GA.
Can you repeat?
Similar type, one question is in practice assignment and one question is in graded assignment.
Yeah. So this we can actually do, right? This was actually mentioned in the normal syllabus itself. It's like normal one. We just need to apply the formula and then we'll be getting it. Okay. So this is a direct formula one. I guess this is this week 2, right?
Yes, sir.
right? You can just do that. Okay. So I just explain the first problem. Okay, you can stop sharing. I'll explain the first problem. Which you said that you didn't get the correct answer. Okay. The directional derivative gas, right?
Yes,
Length
sir.
of
Yes,
gas,
sir.
right?
Yes.
Dou F by dou x is 2x y cube minus 4z at a point 1, 1, 1, 1, comma 1, comma 1. So dou F by dou y
-2.
6x square y square, right?
Yes, sir. I was talking about for dou f by dou x.
Sorry, dou F by dou y 3x square y square, right?
Yes, sir.
Dou by dou z, it's going to be equals to minus 4x, correct? Now if you substitute the value of 1 comma 1 comma 1, this is going to be equals to 2 minus 4 minus 2, this will be equals to 3 and this will be
3
equals to minus
minus 2.
1. Okay. Now the directional derivative of this with respect to this, it's going to be minus 2 comma 3 comma 4 dot product with minus 1
Minus 4. Minus 4.
whole divided by
Root 5.
what?
Root 5.
Minus 2 comma 3 comma
Yeah, yeah,
minus
yeah.
4.
Minus 2 comma
3 minus 4.
okay, okay. Divided by root 5 because the length of this minus 1, 2, 0, that's going to be equal to root 5. Okay, so this will be equals to 2 plus 6 divided by root 5. This will be equals to 8 divided by
3.5, sir.
okay. Did you get the same answer?
Yes.
Bhavya, did you get the same answer?
Yes, sir. It seems I made a calculation mistake the first time round.
Okay. Okay, then. Fine. Okay. If there are no other questions, then you can close it again.
Sir, one question, I think not about this syllabus. Shall we practice for the limit and those things also? But because like I can't see the questions for limit and continuity in
Yeah,
the
yeah.
first thing
Please,
also.
please do prepare for that also. Those also can come. Okay.
They won't come, right?
Yeah, yeah, they can come.
They can come.
Yeah, they are in the syllabus, so they can come. Yes.
Yeah, because I can't find them in the mock and the revision thing, so that's
Yeah.
why.
So
All
just
right.
because few questions were not there, that
No,
doesn't mean
but
that they won't come.
Hari, I think Hari,
Yeah, Ganga.
yeah, it is better to revise that, especially L'Hopital rule, because in one of the revision session it was emphasized on that. So it
Okay.
is better to
Thank you.
revise.
Sure, I'll do. Thank you. Thank you.
Okay. Any other questions?
Sir, please upload the recording, sir. Okay, because
Yeah, yeah.
I joined very late, so I will have to go through that.
May I ask one
Will
more
do.
question again from the same paper?
Regarding
Probably
what?
it's easy. I'm just.
I'm sorry.
It's about eigenvalues and vectors.
Yeah, yeah. What's your question in that? Yeah, you can ask a question, Ravi.
This is the problem.
Huh. Okay, the eigenvalues, can you
Hello.
scroll up, please? The eigenvalues on the corresponding eigenvectors are given.
I
The
am not able
matrix
to
is
hear
ABC.
you.
Okay. They asked me to find the matrix, right? Based on the eigenvalues on the
Seems like
eigenvectors.
there's something wrong with my mic.
What?
You are audible. Rapiji, you are audible.
Yeah, so basically we can do this.
Just give me a couple of minutes, please. I will stop sharing. I will log off and log in again. Just give me a couple of minutes.
Yeah, so just tell me the eigenvectors alone.
8,
Okay, what are the eigenvalues?
8 and 4.
What?
8
8 and
and 4.
8 and 4, okay. Eigenvectors
1, 1.
4 comma
1, 1.
1 comma 1, that is corresponding to 8, and then The other one?
1 comma minus 1.
1 comma minus 1.
Yes.
Right? Okay.
That is A, B.
So what we have is we have A, B, C, D. Okay. And then since lambda 1 plus lambda 2 is equals to the trace of the matrix A plus D, correct? So I know that lambda 1 plus lambda 2 is equals to,
1.
I mean, A plus D is equals to 12, right? This we know, correct?
Yeah.
Okay. And then there is this one other observation you could see here, 1 comma 1 and 1 comma minus 1, they are like perpendicular to each other, right?
Yes.
Correct?
Yeah.
So, huh?
Yes. Yes.
Yes.
Okay, so basically this can either be the, it can be symmetric matrix or it can be this orthogonal matrix. Okay, but I mean it won't be the orthogonal matrix because we have the lambda values as 8 comma 4, right? For the orthogonal matrix, the lambda values will be equals to plus or minus, I mean plus or minus 1, it will be there. So in this particular case, it will be a symmetric matrix. Since the eigenvectors are like perpendicular to each other, then we could like assume that B is equals to C. Can we do that?
Yes, sir.
Okay, our matrix is ABBD. Okay. Then the other one we have is AD minus BC is equals to, AD minus BC will be the determinant, right?
32.
The determinant will be equals to 8 4s are 32. Lambda 1, lambda 2, correct?
Yeah.
Okay. So we have A plus D, we have AD minus BC, and then B. I guess B is equal to C, but then let's not let's not directly assume it. Okay. The other ones we have is we have here AX equals to lambda X, right? So AB CD multiplied by 1 1 should be equals to 8 times of 1 1. This is the first equation, and then we have AB CD multiplied by 1 minus 1, it should be equals to 4 times 1 minus 1. Okay. Sorry. So we have here, this basically implies A plus B is equals to 8. Okay. And then C plus D, right? C plus D will be equals to 8. Okay. This is the first one, and then from these two, what we can get is we can get A plus B is equals to 4. Okay, and then C minus D is equals to
Minus.
C minus D equals to minus 4. Correct? Is this okay? This one? Hello.
It's
We have here A plus B is equals to 2. Right?
Yeah, now we will get all ABCD.
No, C equal to 2.
And then we have C minus D is equals to what? A plus B equals to 8, and then A plus B equals to 4. Okay, that be possible.
A minus B equals to 4.
Okay, sorry. Yeah. A minus B equals to 4. Okay. Now we have C minus D is equals to minus 4. Okay. Based on these two, A plus B equals to 8 and then A minus B equals to 4, we can get the value that 2A is equals to 12 and A is equals to 6, which basically implies B is equals to 2, right? Okay. C plus D equals to 4 and then C minus D is equals to minus 4, which basically implies
C equal to 2,
C is
D
equals
equal
to
to
4, C is equals to 2.
D equal to 6.
You basically add these two, okay? equation 2 and equation 4, if you add, you get 2c is equals to 8 minus 4, 4, which basically gives you c equals to 2. And then
D is equal to 6.
c will be equals to 4.
No, 6. Sorry.
Okay, 6. So our matrix is 6. Yeah.
6, 2, 2, 6.
2, 6.
Yeah.
You remember when I said that B and C can be equal?
Yeah.
They turned out to be equal. Okay. Okay. Is this clear how we found this? ABC?
Yes. Thank you. Thank you.
Okay. So any other questions?
That's all I have.
Okay then. So yeah, all the best for your exam. Thanks. Thank you.
Thank you very much and get well soon. Seems like you are having a bout of cold.
Yeah. It has been there for a long time, but yeah, thanks.
Thank you, sir.
Thank you. Thank you very much.
Thank you.
Night.
Thank you.
Thank you, sir.